to present a heart failure prediction model which has been done as a capstone project for IBM Advanced Data Science Specialization. I would like to share the architecture first. Um, this is the architecture of the model, and here you can see Watson Studio, Apache Spark, Object Storage, Jupyter Notebook, and Watson Machine Learning Service, Node.js, and the data. The steps that I used for creating this is, first I have created IBM Watson Studio Workspace, then Apache Spark Service, then I have used Cloud Object Storage to manage data, and for the lab I used Jupyter Notebook to import data, train and evaluate. First I did import data on heart failure from the GitHub IBM projects, and then I trained the model and then deployed into production using IBM's Watson Machine Learning Service. Then a Node.js web app is deployed on IBM Cloud to call the predictive model hosted in Watson Machine Learning Service. As part of this, initially I did data cleaning and then exploration of data. This is the notebook that I have used. I imported data as a pandas data frame from Apache Spark. So this is the data frame that has been created, and it displayed first 5 rows using the head method. Here you can see different fields of different columns in the data. Average heartbeats per minute, palpitations per day, and then the cholesterol, BMI, heart failure, age, sex, family history, smoker, last 5 years, exercise minutes per week, and then I displayed the bottom 5 records using tail method, and then I used describe method to print the statistics of the data set. Here you can see the statistics. It displayed the count of the records, the mean, standard deviation, and minimum and max value, and 25%, 50%, and 75% the data at 25% level, 50% level, and 75% level. And then I displayed the records in the data frame using the count method. Here it showed 10,800 records for each column. And then I tried to check if there is any missing data using isNull method and displayed first 5 records. So here you can see all having false. So that means there is no null data. And I tried to get the count using this for loop for column in missing data dot columns dot values dot toList, and I printed the column and then the value counts. Here you can see for all the columns we have false and count as 10,800. So that means we don't have any null data in the data set. So we have good data in the data that I got from GitHub. So next I printed the shape of this. It is 10,800 records and we have 10 columns. Next I printed the data types. Here all are integers other than heart failure, family history, sex, and smoker last 5 years. Then I tried to print the correlation between the numeric fields using the COR method. So here it gave all the correlation, and we can see the values here for all the integer values. Next, I tried to correct the formats for all the columns. We have correct formats for all the columns. Then heart rate failure is our target variable, and this is our label. And we will be converting sex, family history, smoker last 5 years into integers using getDummies method. Okay. and we displayed the last 5 records. Here you can see the sex as male or female. Here the last 2 columns. And then I converted family history using the same method get dummies. Here you can see the family history Y or S, no or S. And then I converted smoker last 5 years, and for that also we had yes or no. And I dropped sex from the data frame, and similarly I dropped family history and smoker last 5 years. And we can see here we don't have those fields now. We have only female or male or family history and smoker or not here. Now I printed correlation again. So here you can see the correlation for even for sex and the family history as well as smoker last 5 years or not. I did print the box plot for average beats, heartbeats per minute and heart failure, and we can see the data here. You can see. Similarly, I have print for palpitations per day and heart failure. Here also I can see here the data. And similarly, I had printed for cholesterol and heart failure. And this is the visualization. And for BMI and heart failure also we have like this. You can see clearly how it is being affected. As BMI increases, there is a chance of increasing heart failure. Even when there is low also we can have that. And then I use the SciPy for importing statistics, and I converted even heart failure into integer mode, and I use the Pearson coefficient for printing correlation efficient. So this is how I use the Pearson correlation efficient. And first I have used the BMI and heart failure Y, and you can see the Pearson correlation efficient is 0.13622215, and we can see the p-value as it's very small value. You can see e to the power of minus 46. Then I have printed the Pearson correlation efficient for age and heart failure. You can see a negative correlation efficient, and p-value is less than 0.01. Similarly, we have printed for exercise minutes per week and then heart failure. Why? We can see the negative value as a correlation efficient, and p-value is very less. So I have printed for average heartbeats per minute, palpitations per day, cholesterol, and BMI with respect to heart failure, and we have these values. We can see it's p-value is very less, and e to the power of minus 117, e to the power of minus 8, and here also it is less than 0.01, and this is very less. So I have printed again for female and male. You can see this value inverse, and then family history, and then for smoker. So if you observe the correlation between heart failure and all the features Most of the features of the are having the p-value less than 0.001. So the correlation between heart failure and that feature is statistically significant. So we need to consider those features. And for some of the fields, you observed that coefficient is negative value. So that shows the relationship is negative and moderately strong. So as per this, we have to consider all the features as those were significant in predicting the heart failure rate. Here is the model. So while creating the model, I used uh, Apache Spark data frame. So this is how it is, and we can see the schema of the data here using the print schema. It is integer, and heart rate is string, and sex is string, family is string, smoker last 5 years is string. So I try to show the data again here using the show method, and this is the value of the data for the 20 records. And then I try to describe method and printed the values of mean, min, max, and standard deviation. This is how it was looked. And then I had splitted data using random split. Training data as 80% and test data as 20%. And I used the seed 24. So we have training records of 8,637 and testing records of 2,163. Then I imported all these Apache Spark packages. Then I converted all the string fields to numeric ones using string indexer method. And heart failure and the output column name has come as label. And then for sex, we have sex index. And for family history also, we have family history underscore index. And smoker last 5 years, it has index. So then I created a feature vector using vector assembler. So all the columns I use. Here you can see I use sex underscore index, family history index, and smoker last 5 years index. And the column that we got out of this is features. And I have used random forest classifier. I defined this one as RF. Then this is the label converter that I use to get to string back, index to string. Then I transformed the pipeline and I had displayed the data. So here you can see the sex index, family history index, and smoker index. Still heart rate failure is there. And this is the pipeline that I used for random forest, and these are the stages. First, like we had created the index for all these string columns, and then we use the vector assembler features to get the features column, and we converted the labels back again using label converter. And we had defined the model here as model RF and pipeline underscore RF dot fate, and we use the training data here. And to check the model accuracy and to evaluate, we use the test data. And here we have predictions is equal to model underscore RF dot transform and we had given the test data. And this is the evaluated. We used multi-class classification evaluated, and metric names we used is accuracy. So I got the accuracy and I printed this. I got the accuracy around 87%, and this is the test error. And I imported ML repository client and artifacts, and these are the service path that I use, and the username, password, and instance ID. We created the model artifact using this pipeline underscore artifact is equal to ML repository artifact pipeline RF, and name is the pipeline. And we have provided in the artifact we have provided model underscore RF and the training data, the name of the model, and artifact name. Okay, then we saved the model using this models.save method of ML repository client. I just wanted to get that model, save the model back, and this is how it displayed. And we are going to print the model type, training data schema, creation time, model version, and label for the model. So here you can see this. And this is the creation time of the model, and the label for this model is heart failure, and this is the version. And I just try to load the model again to make sure it was saved correctly using this get method. And we have provided the saved model and UID of this. Let's print that. We just got the name of this loaded model. It's a heart failure prediction model. Then I'm saving this model to Watson machine learning service using this is the code. For authentication purpose, like I use the service path and username and password that I have created. And Watson ML API authenticates all the requests through a token. So we had to request a token from our Watson machine learning service. And this is the token. This is the model URL. I'm going to show here. This is the URL. And these are all the information that I had printed. And then I just read the details of the written model using this, and I displayed here. The name of the model is heart failure prediction model, and this is the model ID. So I just created a new deployment for the model again. These are the data that we had used, and you can see here status as deploy success. So here it shows the model information again. We deployed again. This is the method that I use to get the prediction for the machine learning, and the scoring URL is the one which we got above, and this is the information that we give, and this is the response that we get from there. Okay, so format get prediction ML, and we are providing all the data for a 44 age and a female with low BMI. So we got prediction as Y. This is the model, and I have this as a data product to share with all of you for reviewing my work. This just uses the service path, username and password information, and then this is how it is going to initiate that, and then like it creates a token. Then the method, and when you call the methods, it showed. So if I just checked whether 34-year-old male that smokes with high BMI at risk failure, yes. Is a 30-year-old male not smokes, no family history with high BMI at risk of failure, no. With this, I wanted to end my presentation. Thank you very much for all of you.